we're told to find the area between y equals x squared minus 5x plus 2 and y equals negative x squared plus 5x minus 6 as x goes from 0 to 4. As x goes from 0 to 4. So what I did here is I graphed the two equations in Mathematica, and we see we have this kind of this fish looking thing going on. And already looking at this, and you can do this in your calculator, you can just put it in the y equals section of your calculator and plot it that way. And already looking at this, we'll see we're going to have to figure out the intersection points, and we're going to figure out which graph, because they're switching here, which graph is the upper boundary and which graph is the lower boundary on, we'll call this section 1, section 1 and section 2. Alright, so let's figure out which line is which first. So if you plug it in your y equals, you put them both in, you're going to need to figure that out initially. So what we do is we set these equations equal to, or set our x equal to 0 in both these equations, and let's see where their y-intercepts are. So if I set x equal to 0 here, we'll just call it y1. We'll call this y2. If we set x equal to 0 in y1, we get y1 equals 2, which is right here. So therefore, this blue line, that is the upper limit, and this section here must be x squared minus 5x plus 2. I'll just use blue again. Now our y2, which we don't even have to, we already know that this is y1, but let's go ahead and solve for it anyways, is x equals 0 here, y equals negative 6. That is indeed this spot right here. So this orange line must be negative x squared plus 5x minus 6. Alright, now we see we have an intersection point here and here, and they look like, just looking at the graphs, they look like they're at x equals 1 and x equals 4, but let's go ahead and verify and do this the old-fashioned algebraic way. And the way we do that is we set these two equations equal to each other, and then we're going to solve for the x values. So we take y1 equals to y2, which is x squared minus 5x plus 2 equals negative x squared plus 5x minus 6. And if you don't know why we have to figure out these intersection points, the reason we have to figure out these points is because we're going to need to set up two different integrals, because again, the upper boundaries and the lower boundaries change at whatever this intersection point here, and that one will go from this intersection point to that intersection point. So we're setting ourselves up for success in in constructing both our integrals. But right now it doesn't matter, that part doesn't matter, we're just finding the intercepts. So we got x squared, all this equal to that. Let's go ahead and subtract one side from the other. So I add x squared to both sides. I get 2x squared. I subtract 5x from both sides. I get minus 10x. And I add 6 to both sides, and I get plus 8 equals 0. Alright. Now, we want to solve for our x values, which will in turn be our intercepts. Let's pull a 2 out, because that'll make our lives a little bit easier. So we factor out a 2, and then we have x squared minus 5x now, plus 4 equals 0. Our 2 could just disappear, because if we divide both sides by 2, that'll disappear on the 0. And then we get x minus 4, x minus 1, when we go ahead and factor this down, equals 0. And this indicates that x equals 4, comma, x equals 1, and both these values will set the equation equal to 0. And if you remember what our equation was, it was y1 equals y2. Thus we see that looking at the graph showed us that the intersection point is x equals 1 and the other intersection point is x equals 4. We just verified it algebraically, so we know our 2 points are x equals 1 and x equals 4 where the two graphs meet. Alright, so now we need to set up our integrals. And we'll go ahead and call the first one integral 1. Integral 1. I don't know what. Let's use. Oh, I just used green. Let's go light blue. Alright. Integral 1. And in integral 1, we see that y1, this equation here, is actually higher than y2, this equation here. And this takes effect, this holds true as x goes from 0 to our intersection point. So as x goes from 0 to 1. So the bounds of our integral are going to be 0 to 1. And we're going to take our upper function, our higher function, or our upper boundary, and subtract from it the lower boundary to get the area inside. So we have our upper boundary, which was x squared minus 5x plus 2, minus the lower boundary now, which is, and don't forget that parentheses, negative x squared plus 5x minus 6. And all this with a dx. You need that parentheses because you got to distribute that minus sign. You're subtracting the entire function. You're subtracting the entire y2 from y1. Alright, so let's go ahead. You know my bounds are 0 and 1. I'm not going to keep writing that. I'm lazy. Now we have x squared minus 5x plus 2 plus, because I distribute the minus sign, x squared minus 5x plus 6, all with the dx. Then we have, combining our terms, 2x squared minus 10x plus 8 and we can go ahead and integrate this. We get 2x cubed over 3 minus 10x squared over 2 plus 8x as x goes from 0 to 1, which will be, we can forget the 0 term because I'll just zero everything out, 2/3 minus 5 plus 8, and this will equal 11/3. Alright, but that's not the answer. That's not the answer. We just figured out that inside here, this little area right here, our first area, is 11/3. Alright, now for integral 2. Integral 2, let's zoom out a little bit. This is getting a little messy. Alright, so for integral 2, our bounds switched. So now the negative x squared plus 5x minus 6 is the upper boundary, and the x squared minus 5x plus 2 is the lower boundary. And our bounds are going from the first intersection point, x equals 1, to the second intersection point, x equals 4. So let's get a better color. I always love red. So we got integral 2, our bounds, as we said, as x goes from 1 to 4. Now we're doing y2 minus y1, so we have a negative x squared plus 5x minus 6 minus, all in parentheses, x squared minus 5x plus 2 and 1 to 4. We have, combining our terms, I'm going to skip the distribution part, we have negative 2x squared plus 10, plus 10x minus 8. And we can go ahead and integrate this. We get minus 2x, I don't need my integral sign there. We get minus 2x cubed over 3 plus 10x squared over 2 minus 8x, as x goes from 1 to 4. And we get negative 128. Let's see, 4 and 4 is 16. 4, yep, over 3 plus 80 minus 32. Now we have to do, so we did f of b, now we have to do f of a because it's f of b minus f of a, minus, so now we're going to evaluate all these terms at 1, 2, negative 2 thirds plus 5 minus 8. And when all this is said and done, we get 9. Now that's not our answer either. We have to add both our terms. Now we have to add both our terms. That's too close. Alright, so A1, our first area, area 1, was 11 thirds. Area 2 was 9. And combining them, A1 plus A2 equals 19, 27, 38 thirds. I believe so. And I'm pretty sure that that is the answer to the question. 38 thirds. Actually, we still have to verify on computer software. So I went ahead and typed it in here. What you see here is Mathematica, and I put our first integral. As you see, I have the y1 minus y2 as x goes from 0 to 1, plus, which will be the area of area 2, plus the integral of y2 minus y1 as x goes from 1 to 4. Let's go ahead and evaluate that. We get, in fact, 38 thirds. If you have any questions, just post in the comments or send us another email. Thank you.